Hi class. So for this video, we're gonna use the same curves that we used for example 4, but this time we're gonna rotate the region about a different line instead of the x-axis. So this time, as you can see, we have the same curve, which is y equals x and y equals x squared. But this time we're gonna rotate it about y equals 2. So it's right here. So you can see that this is our cross sections, okay? So it's still a washer, but which one is gonna be the inner and which one is gonna be the outer circle? So you see for example 4, previously, you see right here, x squared is closer to the x-axis, right? Therefore, that one is the inner circle. But if you go to example 5 here, because we are rotating about y equals 2, this time y equals x is gonna be closer to that line y equals 2. Therefore, 2 minus, because we have the distance here from, we have the distance of 2 here, so we're gonna have to take 2 minus x. But anyway, now the inner circle is gonna be 2 minus x, and the outer circle is gonna be 2 minus x squared. So it's changed a little bit. So the inner is 2 minus x, because that one is closer to y is equals 2, and the outer is going to be 2 minus x squared. By the way, these are just a radius. This is not the area. For the area, don't forget we have pi r squared. All right, so now let's take care of the area. The area this time is going to be pi, and then the outer 2 minus x squared minus pi 2 minus x squared. Okay, so for the volumes, we're going to take the integral from 0 to 1 a of x dx. All right, make sure we have to FOIL everything. So if I FOIL and simplify everything, I'm gonna end it up with the integral from 0 to 1 pi x to the 4th minus 5x squared plus 4x dx. That's after I FOIL and simplify, combining like terms. All right, so now we can integrate. We have x to the 5th power divided by 5 minus 5x cubed over 3 plus 4x squared over 2. And then we go from 0 to 1. After you finish with all the calculation, you see that we're going to end it up with pi 8 over 15. So it's 8 pi over 15. All right, so as you can see that we create solids. So those solids are called the solids of revolution because they are obtained by revolving a region about a line. So earlier we have the line equals to y equals 2. Previously, we have the x-axis. So as you can see, you either get a disk, right? Or you get a washer. If you get a disk, so it's really simple, it's just one circle. So you have pi r squared, right? For the cross sections to be washer, we have the outer and the inner. And like I said, the inner is gonna be the one that's closer to the line that we are rotating. Okay, so that's how you figure it out. Now, this time we're gonna use the same, the same curves, which is y equals x. Sorry, it's this one. Y equals x and y equals x squared. However, this time we're gonna go and rotate about the line x equals to -1. So now we have a vertical line and we rotate it, okay? So you see that we changed to y. So that's why we can no longer use y equals x. We have to change it to x equals y. We can no longer use y equals x squared. We have to change it to x equals to square root of y. Okay, so now we have a new cross section, right? We have a new solid, a new cross section, and this time a y is going to change. So let's take a look at, okay, so I'm still going to write outer minus inner. Okay, but which one is the outer and which one is the inner? As you can see right there, you see x equals to -1. So which one is closer to that line is the x equals y, right? And the outer one, the further one is x equal to square root of y. However, we're not doing with that y-axis. We shift it to -1. So you have to calculate the distance from that line, which is -1, all the way to y and all the way to square root of y. Therefore, the area is going to be pi 1 plus, so we're doing the outer first. So the outer is the square root, and then it's pi r squared, so you have to square it, minus pi, and then this one is just 1 plus y squared. Okay, so now we are ready to plug it in for volumes. Don't forget, this time it's gonna be dy. So I have ay, so it has to be dy. And then we go from 0 to 1. Let's say, okay, of course, eventually we have to take out pi. Anyway, once again, we have the FOIL, do all that fun stuff. So we ended up with 2 square root of pi minus 2 square root of y minus y squared dy. Okay, don't forget I already FOIL and simplify everything. So we ended up with pi, and now we take the antiderivative. So 4y 3/2 over 3 minus y squared over 2 minus y cubed over 3. 0 to 1. And then we ended up with 1/2. Right? So it's pi over 2. Okay. Like I said, I FOIL, do all that work already. Okay, the last example I want to show you, this time we do not have a disk. So we consider the volumes of a pyramid whose base is a square. So this is the your solid, right? So you slap all the square in, and then we go to the vertex, which is the origin, and then the square gets smaller, but they're all square. Okay, so we have to consider the area of each square here. So how do I figure out the area? I need the side, right? So the side here, in this case, I'm going to call S, right? So, so we have X is from 0 to that point X, right? And then we have the height, which is over here. But the side of the square is going to be S, right? Okay, so it's getting it's going to be bigger, right? So we can use proportion to solve for S, because that's what we need. We need S because we need to find the size so we can figure out the area. So if I go X over H, that's proportional to S over 2 divided by L over 2, right? Which is just S over L. Now, I want to solve for S. So we're going to cross multiply, right? So S times H is going to be X times L. So H is going to be LX over H. Okay, so from there, I'm going to figure out the area. And then don't forget, this time the area is the area of a square, which is just side squared, right? So in this case, it's going to be everything's, this whole thing square, this whole thing square. So I get L squared over H squared times X squared. Okay, so we're going to integrate that from 0 to H. And then I have AX dx, which is what? 0 to H. L squared H squared X squared dx. Okay, notice that in this case, L squared and H squared is just constant. So I can just take it out and then I integrate X. So I get X cubed over 3 from 0 to H. So I'm going to end it up with L squared H over 3. Okay, it's actually H cubed over H squared. I just simplify it. So that's how I got L squared H over 3.